Hello, let's continue our Sudoku adventure with Yod by Jean. So we have normal 6x6 Sudoku rules. So within this bold border, in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have region sublines. Blue lines in the grid are region sublines. Lines are split into segments by region borders. Within each individual line, the sum of the digits on each segment is the same. So this line here, notice it goes off the grid. But when it goes off the grid, that's a region border. So here, these two cells are a segment, and then we go through a region border. So this is another segment, and then we go through another region border. This is a third segment. Every single segment on the same line has the same sum. So if this was 2, 3, we would sum to 5. This would be 5, and this would be 5. And the outside the grid clues are digits are going to be used for numbered rooms. This is an escape the grid. And so this one, just to show you how this works, these two are going to be a segment, and then I believe all of these are one segment because this does not cross a region border, as far as I can tell. Yeah, I mean, it doesn't, right? We're not entering or leaving a region because we're outside the grid the whole time. So these two add to whatever these add to. Now notice that digits outside the grid do not have to it's not non-repeat outside the grid. The non-repeat is only in the rows and columns within. I mean, otherwise this would be impossible. I'm not going to think about that too much more because we're still going over the rules. So when we do place a digit outside the grid, it must we only have to do that for where the region sum line exists. We have little gray outlines telling us also fill these ones. Whatever that digit is, it's a numbered rooms clue. So what we do is we look at the digit closest to it in the grid. Say this was a 4, and we count 1, 2, 3, 4, and that is where the 3 goes because that was a 3. If this was a 2, that's where the 2 goes. If this was a 3, the 2 would go here, right? You just count that much away. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Let's think about this for a second. So it's tempting to say these could all be ones. And they just tell you where the 1 is in that row or column. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In fact, that's what it is. These are all ones because the maximum this can add to is 5, 6, which is 11. And the minimum this can add to is all of them being 1, making them add to 11 because there's 11 cells. I mean, this is 6, this is 5. 6 plus 5 is 11. So they all just point to where the 1 is. So that means the 1's somewhere down here. This 5 or 6 tells us it's down here. So this is 2, 3, 4 because it can't be 1. But now let's think about this now. So this can't be a 2 because these two add to at least 3. But it means these add to 3 or 4, which means they're either a 1, 2 pair or a 1, 3 pair, putting the 1 in one of these two. If this is a 1, it just says, hey, there's a 1 where I am. That's perfectly fine. It cannot be a 2 because a 2 would put a 1 here and then there wouldn't be a 1 here to add to 3. So it's not a 2. The 3 would put a 1 here. Now, if this was a 1, this would be a 2. And that's fine, I guess. We know the 4 is in one of these two. If this was a 4, the 1 goes here. That's also fine. So this is 3 or 4. So whatever this 3 or 4 is, it ends up over here somewhere. We don't get much, do we? Is there some relationship here? So, okay, so we can say there's a relationship between these two digits in that one of them will be low, one will be high. Why? Well, as soon as we have a 1, 2, or 3 in here, that tells us that the 1 is in one of these 3, which then forces the 1 to be over here. And that's going to be in 4, 5, or 6, right? We can't repeat in the box, so we can't do 2 lows or 2 highs because that would, by indexing, repeat the 1 in the box. And so the high here could only be a 4, and the high here could only be a 5. And this 5 doesn't work, actually. That's interesting, because if this was a 5, this is a 6, and that tells us that a 3 or a 4 is where we just put that 5. Right? If this was a 5, by Sudoku this is a 6, then this 3 or 4 has to go right here by indexing, And it's a 5 already. It can't be a 3 or 4. So we put a 4 here, and then this is 1, 2, or 3. Sorry, I shouldn't have had those corner marked. But we do know the ones down here, so this is a 1, and that just points at itself, unfortunately. And the 4 is placed, and then this is the 2, 3. Awesome. What's next? 2, 3 pair, 1, 4. We don't know what's going on here. Oh, so since this is a 4, this would have to be a 2 for it to point at the 4, but it's not. For this to be a 4, this would have to be a 2 in order for that to be consistent. So this is a 3, which makes that a 3, which makes that a 2, and that's a 3. So our sum is 3 now. That's not a 2, which means the 1's not there. All right. This 3 put a 1 here. This 4 put a 1 there. That's a 3, which puts a 1 there. Okay. Interesting stuff. So this has to be high. In fact, actually, this is 5. Okay. Now these don't have to be, but we know they're 2, 6 anyway. I guess they did have to be, because if this is one of each, this is one of each, this is also one of each. So never mind. 2 would put a 1 here, 6 would put a 1 there. Both seem viable. We do know there's a 1 in one of these two. These 3 digits are the, actually we should just use roping. This is 5, 6 only. This is 2, 5, 6. These 3 digits are 2, 4, 6. So the 4 is over here somewhere. This is 2, 6. Might as well just fill it out. We know the 3 is down here somewhere. 2, 3, 6. What am I missing? I placed those. 2, 5, or 6. Well, we know this can't be a 2 because it would place the 1 right there. And it's not. So this is the 2. Oh, because we placed the 1. I think I didn't, yeah, I didn't follow up on that. All right. 5, 6 pair means these aren't 6. What's next? Right, and I had the 1 in one of those, so I should have the 5, 6 there. Did I miss? These are 4, 5, 6. Yeah. This 5, 6 pair and this 2, 6 pair tell us all about the 1s. Four looks down, so 4 is one of these two. What am I missing here? I've done the blue lines. I've done all the numbered rooms as best I can. Unless it's a relationship here. But let's look to see if there's anything I might have just missed Sudoku-wise first. 5's down here. 5's one of these two. Not really helpful. These are 1, 2, 3, 4. All right, so it might have something to do with the relationship here. Like, if this is 6, then this is 5, this is 6. Wait, hold on. How does this work? Maybe this only works one way. Let me go through this again, because I might have made a mistake. If this was 6... No, it does work. If this is 6, then that's not a 1. So that's our 1, that's our 2, that's a 1, and that makes this a 5 and this a 6. Okay, so that's one option. And if this was 2 and 6, this would be the 1, this would be the 1, this would be 5, and this would be 6. So it's consistent either way. Why does 1 not work? This is 1, 2, 4. What am I not seeing Sudoku-wise? This is 3, 4, 5, 6. So the 5's down here. Was it this 3? Oh, it was this 3. That's what I'm missing. This is 6 because the 3 went there. So that's 5, that's 6, that's 5. The 5 puts the 1 there, the 6 puts the 1 there. That makes this a 2 and this the 6. There we go. That's 4. I was like, how is this going to work? That's 2 and 6. That's 4, 2, 3, and 6. We get the 5 and 6 and 4. This is 5. What's this? 4, 5, 3, 2, and 3. All right. Yeah, I just didn't follow up on the numbered rooms very well in my solve. If I'd done that, it would have been much quicker, but that's how it goes. How'd you do?